Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3779 called minimum number of operations to have distinct elements. And so yeah, so you're given this integer array nums, and basically you just want to keep removing the first three elements until you can't. So you just want to keep doing this until there is at least one element in the array left, and it has no duplicate values. So for example, 3 has a frequency that's bigger than 1, so there are duplicate values. This would not, so it only takes one operation to reach that state by deleting the first three elements. So let's do exactly that. So let's just keep saying while length of set of nums. So how do we make sure there are no duplicates? So if it's less than the length of nums, then we know that the unique number of elements is less than the total number of elements. So there are still duplicates, right? And because this is an OR condition right here, there are at least elements in nums. That means we can still delete. So we have to keep track of the total number of turns. And then if there's still elements, we're going to delete nums of 0. And we do this 3 times, right? And then we increment the number of turns, right? Until we can't do that anymore. So deleting 3, then deleting 8, then deleting 3. So that's one turn, and this is unique, so we're going to return turns when this is false, right? Because the length set of nums is 3, the length of nums is 3. So let's run this and submit it. And what you'll notice is that this times out because this is actually very expensive, and then so is this. So let's first turn this. If we want to keep track of the number of unique elements, let's just keep track of all the elements first, right? So however many keys in this counter are going to be the number of unique elements, right? And then as we pop from the front, let's just call this a value, and let's also turn nums into a doubly ended linked list so that we can pop from the front a little bit faster than this. So we're going to get the first value, and we're just going to say C of first value. We're going to decrement the number of times it appears, and then if this is 0, meaning it doesn't appear anymore, then we're just going to delete it from the hash map. That's it, right? And let's do that for this as well. We're going to do this 3 times. And last but not least, again, if there's no frequency, that means that value doesn't exist anymore, right? So cool. So we can actually do this by doing a nums.popleft, which actually removes the leftmost element in constant time, because this is a doubly ended linked list now. And that helps a little bit, because now instead of doing this, which is expensive, we can just say the total number of elements is length of nums from the start. And if this is true, then that's one less element, right? So in that case, actually, we're always going to be subtracting 1, because we're always removing an element if we can, because if we remove from the front, that's automatically one less element. So if it's less than total, instead of recomputing the length of nums, and if the length of the unique values, which is the point of the keys in this hash map, which we can probably just call it frequency for better naming, frequency, just to make this more clear. Cool. So if the length of frequency is less than the total, there are still duplicate elements. And there's has to be at least one element left to at least remove in the entire array itself. And then let's run this. So it's going to calculate the total number of turns it takes, right? So let's submit this. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.